end of the last video, we introduced this idea of r squared, and I told you I would come back in the next video to talk about it. So here we are. Before we reach r squared, though, I wanted to do a quick review from chapter 4 of the correlation coefficient, which is just the letter r with no square on it. So the correlation coefficient r is going to give us the strength and direction of the linear relationship between our two quantitative variables. R is between -1 and +1. The closer it is to 0, that means there's no linear relationship there. It's either scattered glitter dust or it's curved or something else, but there's no linear relationship. The closer regular R is to either -1 or +1, the stronger the linear relationship. Okay, so that's one piece of the R. Now, if we take R and we square it, so we multiply it by itself, that's called the coefficient of determination. So r squared does a couple of things for us. It tells us how good the predictions are that we can make with our regression line, which is a really important feature. You don't want to be using that regression line if it's not going to make useful predictions. It's also the percentage that describes the variation in y that is explained by the model. That is a huge mouthful to just say that where we put the line at and where the dots fall in relationship to that, it's giving us kind of that variation that comes from the location we put the line. Typically in this class, you're going to use r squared just to make an analysis of how good of predictions you're going to make. But if you see a question that says on the homework that says, what's the percentage of variation? That's also the r squared value as well. And then another definition would be it's the quantitative measure of the explanatory power of the model. That means how good it's going to be at telling us that cause and effect relationship. Okay, so the properties for r squared, if you think back to math, anytime you square a number, it's either got to be positive or 0. 0 would be the smallest. So r squared is going to have 0 as the lower bound and 1 as the upper bound. The closer r squared is to 0, the worse this line is at making predictions. You're not going to want to use it if it's getting close to 0. If r squared is closer to 1 and certainly bigger than 0.5, then you're looking at a much more useful model and much more useful predictions. So let's revisit the ice cream example. The r squared value on the ice cream example is 0.96. So a couple questions. Should we expect good predictions? And if so, then what values of the explanatory variable are we going to use? And when are you going to start running into extrapolation? So the first question, do we get good predictions? Well, 0.96, that is really close to 1. So yeah, we're going to get some great predictions out of that. As far as the values of the explanatory variable and where I'm going to hit extrapolation, I'd probably go out 1 degree in either direction on this model. So it looks like my lowest value is 12, x equals 12 degrees. So I'd probably say maybe 11 degrees. And then on the upper end, the biggest one we have a value for is x equals 25 degrees. So maybe one more would be 26. So a good range of values would be 11 and 26. And if I'm going for anything outside of that, so if I chose to plug in 8 or I chose to plug in 30, then I'm starting to run into more extrapolation issues. So let's take a look again at that coral data. So flip back and I'll pull up that spreadsheet and we'll talk about the r squared value for that one quick too. All right, so here we are back with the scatter plot and all of our work for the coral reef models. And I just want to revisit our r squared value. So our r squared is 0.7458. Remember, we got that the same time we added the equation to that chart. You can also get it by just taking r and multiplying it by itself. But with an r squared of 0.7458, that is definitely on the higher side and closer to +1. So I would say, yeah, we're going to get some pretty good predictions on here. And a way of matching that scatter plot up with this idea is that the points are falling fairly close to the line, which should give us some idea that that line then is going to make pretty good predictions. All right.